Hi everyone. Hi Billy, Valerie, Olive, Athena, and Hendrix. The other day I learned that Valerie was asking about what makes some liquids thicker than others, meaning they don't all flow as easily as water. Well, this is a little bit difficult to explain. I can at least show you some of this and give you some thoughts. One of the easiest liquids to flow, of course, is what else? Water. All right. Not everything flows that easily. Just for example, this is maple syrup. Okay. I can pour that into the pitcher because when I'm done with it, I can pour it right back into the bottle. So let's look at that and see how it flows. Well, it flows all right, but not as easily as water. We'll pour it back the other way. And again, see, it flows. You say it took a lot longer to get that syrup back in the bottle than it would have taken the water, didn't it? All right. Now some of these other ones, I'll have trouble pouring at all. So I'll show you those. Put the cap back on so we don't have an accident. This is molasses. Let's try, I guess we can put the molasses in here. It won't hurt if a little bit of syrup gets in there with it. Now watch this stuff. My, that is as slow as molasses, which will give you an idea of where that expression came from. Now, I can't show it to you now, but when it gets really cold, the molasses pours even more slowly. So the expression there is as slow as molasses in January. Look how long it's taking for that molasses to get back in the jar. It'll get there. It's going to take quite some time. Even thicker than that, I'm not even going to take this out of the jar because I don't have to. This is honey. Now when you pour it, it takes forever. But there's an air bubble at the top here. Now, watch when I turn this upside down. Watch how slowly that air bubble goes up from the bottom to the top. So that is really some thick stuff there. And there's a liquid that is so thick that they even advertise how slowly it flows, and that's ketchup. Made right here in good old Pittsburgh. Now, you notice we have it stored upside down? Because if we store it like this, oh, it flops back down there again. But sometimes it takes too long. So we store it upside down. So all of these fluids are different in thickness. And again, we call it, you don't need to remember the term viscosity. It doesn't have anything to do with how dense or how heavy they are. Okay? It just has to do with the particles of the liquid flowing past one another. Now, do you remember what a liquid is? Okay? Anything that has its definite volume, in other words, it occupies the same amount of space no matter what container it's in, but it takes up the shape of the container. That's a liquid. Okay? These all take up the shape of the container, even if it may take a while. But if you leave them alone, and if there's gravity around, they'll be held down in the container, and they'll take up the shape of the container. Now, one thing more I want to show you with water, with alcohol. Do you remember me telling you that water molecules attract each other? Well, they do, okay? They're like little magnets with a North Pole and a South Pole. And when they're free like this, and you can't see them. Remember I told you they are so tiny it would be like looking at a golf ball from 1,000 miles away? Well, they do attract each other. They turn so that the North Pole of one water particle and the South Pole of another come together, and they attract. Okay. Now, water will still evaporate in spite of their attraction for one another if you give it a chance. So if I dip this Q-tip into water, put it on the back of my hand, it feels cool. Even cooler when you blow across it. Now, if you do the same thing with alcohol, and let me tell you, don't do this yourself. Even if you have, this is rubbing alcohol, even if you have it around the house. But the particles that make up alcohol do not attract one another. So what you want to do there, and again, you have mom or dad do this, put the other end of the Q-tip into the alcohol. Put that on the back of your hand. Alcohol here, water here. And you will notice which one feels colder. It's the alcohol, because alcohol evaporates faster. And evaporation carries away heat. That's why we sweat, to keep our bodies cool. And since the alcohol molecules don't attract each other, and the water molecules do, molecules are little particles that make up matter, then the alcohol next time raise your hand when you have something to say. Okay? But anyway, alcohol evaporates faster because its particles don't attract each other. Well, I hope you know a little something about liquids and how thick they are. Any thicker than this and it would be a solid, but that's for another day. In the meantime, bye-bye.